Welcome to Maths and Science by IITIAN channel. In this lecture, I will be taking up a very important topic in mathematics, that is calculus, and in that very important topic of finding the definite integral, and in this definite integral, it is not an ordinary integral, it behaves differently under different situations. It does not yield a specific value or a definite value as in the ordinary definite integrals, and it will, on certain conditions, it will not yield any value. Under certain conditions, it will yield a specific value. This is a very good example on definite integrals, their application and understanding the behavior of definite integrals, and very useful for CBSE, Class 12, IIT JEE Advanced, IIT JEE Mains, and also for CSIR NET examinations and other mathematics aspirants. This is a very good example of improper integral. Improper integral which cannot be solved without certain assumptions, and it may not yield the specific value as in the ordinary definite integration. There will be points of singularity here where the integrand will not be definable. There will be divergence and convergence. Divergence means when a definite integral does not yield any value, it is called as that particular definite integral does not give a specific value, hence it diverges. And third is convergence. If a specific integral, definite integral under specific considerations or conditions, if it yields a definite value, it is told it is a convergent. It yields to convergence. Now, in this particular example, by taking an example, we will be clearing the concepts on improper integrals, their applications, singularity, divergence and convergence of a definite integral, and what are the conditions under which the particular definite integral converges or diverges. Now, we will take example. It looks very simple, but it is not a simple definite integral. It is not a simple one. We have to find out its behavior under various conditions before coming to a conclusion. It will be a fit type of example for JEE Advanced and JEE Mains examination, where multiple answers may be required to be given in assertion and reason type of questions or multiple correct answers questions. Now, the question is 0 to infinity, we have to integrate the function 1 by x minus a to the power of n dx. That means the question is find the integral value, definite integral value 0 to infinity 1 by x minus a to the power of n dx is equal to how much? Here we have to utilize the concept of singularity, divergent and convergence knowledge of definite integrals, and also knowledge of improper integrals. Let us try to solve it. What is the question given? Question given is to find the value of integration definite integral 0 to infinity 1 by x minus a to the power of n dx is equal to how much? Let us try to solve it. Here A and n are also arbitrary, they vary on the real line from minus infinity to plus infinity, excluding minus infinity and plus infinity. We have to find out the integrand value with respect to x. X is varying from 0 to infinity. You have to make sure about this. Solution. Let us say function x is equal to 1 by x minus a to the power of n. Then it implies, first condition, let x is equal to a for any value of n. Function x tends to 1 by a minus a to the power of n, that tends to 1 by 0 to the power of n, that tends to infinity. That means it is not definable. Function x tends to infinity. That means diverges. Hence, integrand diverges at x is equal to a. That implies integrand 0 to infinity 1 by x minus a to the power of n dx diverges or does not have any value, definite value at x is equal to a. That implies x is equal to a is a point of singularity. It is a point of singularity where you are unable to define the integrand. It tends to infinity. Now, second case, let us say, let a is equal to 0, but x is not equal to a. X is not equal to a, but a is equal to 0. Because x is equal to a, it is not definable. We have already found it's a point of singularity. Then function x will be 1 by x minus 0 to the power of n, that is equal to 1 by x to the power of n. Now, what is the integrand value? I is equal to integral 0 to infinity function x dx, that is equal to 0 to infinity when a is equal to 0 and x is not equal to a, that is 1 by x to the power of n dx. This will be equal to integral x to the power of minus n 0 to infinity dx, that is equal to x to the power of minus n plus 1 divided by minus n plus 1 limits 0 to infinity, that is equal to minus infinity, not minus infinity, it is infinity, infinity to the power of minus n plus 1 divided by minus n plus 1 minus 0 to the power of minus n plus 1 divided by minus n plus 1. When n is equal to 1, the above value becomes 0 by 0. this becomes minus infinity to the power of 0 by 0 minus 0 by 0 when n is equal to 1. 0 to the power of 0 by 0, which is undefined. Hence we can say it diverges. We don't have a fixed value for it. When n is greater than 1, what happens? The value of I will be, definite integral value will be infinity minus n plus 1 by minus n plus 1 minus 0 to the power of minus n plus 1 divided by minus n plus 1. Here n is greater than 1. N is greater than 1 means this value will be negative. This value will be negative. And this value will be 0. And this value will be negative. And this will converge. Because infinity to the power of minus negative value divided by some negative value, it converges. When n is less than 1, what will be the value of I? I is equal to infinity to the power of minus n plus 1 divided by minus n plus 1 minus 0 to the power of minus n plus 1 divided by minus n plus 1. Try to understand the concept. Minus n plus 1 will be when n is equal to less than 1. This will be positive. This will be positive. This will be positive. This will be positive. N is less than 1. That implies infinity to the power of positive power. It positive power greater than 1 plus 1, n is equal to, let us say, less than 1 means n is equal to, let us say, 0. Then what happens? Infinity to the power of 1. N is equal to minus 1 means infinity to the power of 2. That means it diverges. What is the conclusion here we have got? That when a is equal to 0 and x is not equal to a, integral 0 to infinity 1 by x minus a to the power of n dx is going to be, it will be equal to integral 0 to infinity 1 by x to the power of n dx will be answer. Converges if n is greater than 1 and diverges if n is less than or equal to 1. Hence, it is not giving a particular value when a is equal to 0. We got a behavior of it. Hence, we cannot say that this is the particular value of the definite integral. Hence, a is equal to 0, not acceptable. X is equal to a, not acceptable. Now we got some conclusions. Now we will further analyze it. It's an advanced level mathematics. We should understand and analyze each and every possibility. We cannot just conclude the answer, and in JEE Advanced, if multiple answer questions are given, you should answer them like this. Now what are the other things? A is equal to 0, we have told it diverges, and x is equal to a, not possible. Then case 1, another case, let us say a is greater than 0. What happens to the integrand? Let us slowly if a is equal to a is greater than 0, for a function x is equal to 1 by x minus a to the power of n. The singularity lies in the interval 0 to infinity. Yes, definitely. Integral 0 to infinity function x dx is equal to x and a. Both are moving together in the same interval, in the same range. 1 by x minus a to the power of n dx. That means if a is greater than 0, x is also greater than 0 because it moves from 0 to infinity. If a is greater than 0, there will be a point of singularity at x is equal to a, because we are taking the range of x from 0 to infinity. A value is also from 0 to infinity. Then there will be a point of singularity at some point where x will be equal to 0. When a is greater than 0, there will be some point where x will be equal to a in the range 0 to infinity. That means when a is greater than 0, this particular integrand 0 to infinity 1 by x minus a to the power of n dx will diverge. Because at x is equal to a, we have defined there is no value, it diverges. There will be some point. For example, in 0 to infinity I have taken a point on 101. But a is also greater than 0, it can be 101. There will be some point where x becomes equal to a, and at that point there will be a divergence. That means it is not converging to a fixed value. Hence at a is equal to 0, it is not converging. A is greater than 0. That means at a is equal to 0 and a is greater than 0, I diverges for any value of n. These two things we have seen. Now, what we have to find is now, if a is less than 0, what happens? If a is less than 0, integral 0 to infinity 1 by x minus a to the power of n dx. A is less than 0 means x minus a will be always greater than 0, because x value is varying from 0 to infinity. Here you just see, we are not doing the mathematics here, we are analyzing logically. X varies from 0 to infinity. A is less than 0 implies x minus a will always be a positive value. For any value of n, it will be a positive value, and integrand 0 to infinity 1 by x minus a to the power of n dx is equal to minus a to the power of 1 minus n whole divided by n minus 1. Provided n is greater than 1. Here you just see, if n is greater than 1 only, 1 by x to the power of n dx converges. Similarly, this tends to certain value when a is less than 0. In that case, we have made it as a is equal to 0. Here we are discussing about a is less than 0. hence it will converge. That means ultimately answer to the problem integral 0 to infinity 1 by x minus a to the power of n dx is equal to it will converge to a value minus a to the power of 1 minus n divided by n minus 1 if a is less than 0 and n is greater than 1. Otherwise, it diverges for all other values. For all other conditions. There can be multiple questions can be developed on this, like this is given a simple question like behavior of 0 to infinity 1 by x minus a to the power of n dx. It converges when n is less than 1. It converges when n is a is greater than 0. It diverges. It converges. All these can be mixed and a question can be framed on this. If you know the concepts, you will be able to understand and you will be able to answer the questions. Please try to develop the concepts and the value of it will have a definite value when a is less than 0 and n is greater than 1. With this, I wanted to conclude this lecture. Please try to see the lecture again and again. If clarity is required, please ask me any questions in the comments column so that I will reply to your questions. Please try to understand this concept. This concept is about singularity, about convergence, about divergence of a definite integral, and about behavior of definite integral under various conditions. Thank you for listening to me. Best of luck to everybody. If there is a value addition because of this lecture to you, kindly share and subscribe to my channel Maths and Science by IITIAN. Thank you. Best of luck.